Hello all. So in this video, we will learn something important about a metric called receiver operating characteristic curve and AOC. So this is also one of the important metric for the binary classification, especially for binary classification. Though we have certain ROC curve for the multi classification also, but that is beyond the scope, and generally it is only useful for binary classification in general. But we have certain changes in the binary classification to compensate for the multi-class classification as well. But for now, we will just study the ROC curve for the binary classification. So ROC curve is a receiver operating characteristic curve, and the concept was given during the World War II by the electronic and the radio engineers basically. So to understand this basic idea, I have taken this dummy data set wherein the x's are my independent variable while y is my target variable, and y hat gives the probability. So the y hat gives the probability. So suppose my x1 has a class label of actual class level. This is actual class level of 1 to 0 and all these things. And similarly my probability. So for 1 my probability is 0.98. For 2 it is probability of 95. For 3 it is probability of 90. So it is 0. So basically this is a misclassified point, but does not matter for this particular ROC curve. X4 is the probability is 0.8 and x5 is probability of 0.9. So for this default data or the default predictions, I have my threshold. As I have explained in the last video, is 0.5. Threshold is the pivot probability, which I would say that something which is above 0.5 is classified as 1, something below 0.5 is classified as 0 or the negative class. One thing you should note that I have sorted this y hat as per the decreasing order of y hat. So this is high and this is low. So this is very much important while constructing an ROC curve. Also, one important thing which I would tell you is that these work on the order of probability scores. So probability is important. These work on the probability scores, but more than that, it works on the ordering of the probability scores. So always while making a ROC curve, what you should do, you should sort my predicted probability in the decreasing order. This is the first step. Now the second step is to alter or to change the thresholds. So let me explain you this by this important examples which I have made. So suppose initially, right, whatever the classification has been done by this has a threshold of 0.5 probability. So whatever probability, general probability, if I have above 0.5, it will be classified as 1, and whatever below 0.5, I will classify it 0. And this is a misclassified point because its probability should be 0. Actually, predicted probability should be 0. 0, but actually, predicted probability should be 1, but it is classified 0. Actually, the probability is 0.9. So it is somewhat misclassified. But don't worry. We'll just look at this, how we can change our threshold and we can make our AOC curve. So first of all, first step, what I will change, I'll change my threshold from 0.5 to tau1, which is 0.98. Remember, we always express my threshold as tau. So this is called tau. So first what I will do, I will change my threshold from 0.5 to 0.98. So what will happen? If my y hat is greater than or equal to tau1, then y is equal to 1. else y is equal to 0. So if my prediction, this is when my threshold is 0.98. So suppose I change my threshold to 0.8. So what will happen? This one will become 1 because why? Because my y hat is greater than or equal to 0.98 here. And all the rest are below this, so it will take the 0 level. Secondly, what I will do, I will again change this tau to threshold to 0.95. So how this will work? So suppose if my y hat is greater than or equal to tau 2 or 0.95, then y equal to 1 or else y is equal to 0. So here I get all these two as 1 and the rest of the 3s are 0. Similarly, tau 3, which is 0.90. So if my y hat is greater than equal to tau 3, then y is equal to 1, else y is equal to 0. So all the values above 0.9 and 0.9 will be 1, and all the values below it will be classified as a negative class. Similarly, tau 4 and similarly tau 5. So when I'm changing the threshold, each will generate its own confusion matrix. Each one of will generate its own confusion matrix. So this is suppose actual and this is predicted. So what is my true positive? What is my true negative? We can actually make it from here. Okay. So we can get it from here. So each of the threshold will have its own confusion matrix because my values will be changing. Okay, so here my true positives, if I talk about my true positives, are 4 basically for this data point, and my false positive will be like this is predicted is 0, so this will be negative, and my false negative will have 1 value, this. So this is the data. So if I will change, my values will start changing here. True negative is 0, true negative. This is a very dummy data set. That is why you can see here. In this case, what it will become? It will become something like 2, 3, 0, 0. This will become 3, 3. Sorry, 3, 2. Then it will become, so every time my confusion matrix will change depending upon the data set. Since it's a dummy data sets, my confusion matrix has zeros and all, but otherwise my values will change. So each of my confusion matrix will have a false positive rate and a true positive rate. Each confusion matrix will have my false positive rate and my true positive rate. Now, my third task and my final task is to plot all this true positive rate. So when I will plot my false positive rate in the x-axis and true positive rate in the y-axis, so this is suppose my point number 1, which have false positive rate as this and true positive rate as this. This is my second point, maybe. This is my third point. This is my fourth. So taking every pair of true positive rate and false positive rate, I will plot it on the x and y axis, and then I will get a curve. This curve is what is called an ROC curve. And the area under this curve, this area is called AOC, or area under the curve. This is actually AUC. This is AUC, area under the curve. This is how you will make a receiver operating characteristic curve. And since my FPR can take the values between 0 and 1, similarly my TPR can take value between 0 and 1. So it is a square by default. This is a square where this is 0 and this is 1 and this is 0 and this is 1. This is FPR and this is TPR. So this is a square of area 1 square, maybe it's like the area is 1 unit, and this hashed line in between is 0.5. So this line is dividing my ROC curve into two two halves. Now I want that my AUC scores should be high. Why? Because ideally, if my false positive rates are much lesser and my true positive rates are more, so what my ideal ROC curve will look, it will look something like this. Why? Because every time I want my false positive rate to be less and less and true positive rates to be more. So more my area under the curve, under the ROC curve, the more better my model is, basically. This is what the idea which an AUC scores give. Also, you should understand all this depends upon the ordering of the probabilities. So once the probability is ordered properly, then only we can make it like this. Now this is when I'm taking, suppose, a random model. Suppose I'm taking a random model. So what my random model is does, it actually just gives arbitrary class 0 and 1 without any logic behind anything. So what in this case, my ROC curve score, AOC score will be 0.5. Why? Because it's a random model. It will give arbitrarily any class to any of my data points. So in that case, I will have my AOC score as 0.5. In some cases, suppose I did a mistake in my data set. I did some mistake in my data set cleaning or something like that in my model construction. It may happen that at that point of time, my AOC scores may be less than 0.5 also. It will be like this. So that is the case when some mistake has happened. Then what you have to do, you should just swap the class level. So if I get yi is equal to 1 here, and I get such a class level like such a ROC curve like this, what I should do, I simply swap this with yi equal to 0 and vice versa. So this curve will just swap and it will become like this. So whenever your AOC score is less than 0.5, you just swap your class levels and it will become greater than 0.5. So this is 2 to 3 things which is much important to understand about AOC and ROC, AOC scores and ROC curve. So basically you have to understand that the more the AOC, more the area under the curve, more is my model performance. My model performance always depends upon area under this scores. Sometimes it might happen that if you have a imbalanced data set, so it might happen that your AOC scores can be greater, but your actual model performance may not be that okay. So that is one of the case. So generally in imbalanced data set, we have certain techniques to make it proper, make it balanced, and then we can look at the AOC scores and all. I hope this AOC and ROC is clear with you. ROC is the curve and AOC is the scores. So that's it for the video. Thank you.